Hi there, it's Miss Linneo. This is part one of a series of videos to help you review factoring polynomials. This first video will be on factoring quadratics. If you feel that anytime in the video you feel that you don't need to review this, please move forward to part two of factoring quadratics. So we're going to start off with the simplest case of factoring quadratics, and that is when the leading coefficient is 1. So we don't have to factor anything out of our polynomial here because the leading coefficient in front of x squared is 1. So here we're simply looking at factors of 20 that add up to -9. So what I like to do is list all of the factors of 20 off to the side. So we know obviously that 20 times 1 gives us 20, 2 times 10 gives us 20, 4 times 5 gives us 20, and that's all that I can think of at this moment. So let's check which of those add up to -9. Well, we know that if they're going to add together, they both have to be negative. They both have to be negative because we want a positive number. So we're looking for two negative numbers. They're going to multiply to give us a positive number. Only two numbers here would be 4 and 5, and they're both going to be negative. So let's double check. Does -4 plus -5 give us -9? That works. And -4 times -5, those are going to multiply together to give us positive 20. So we have x minus 4 times x minus 5. And that should be our factored form of the polynomial above. Now one way to check that this works is to, of course, multiply these out. So this would be our answer. So that's what we would circle in the problem. But here's our check. So we would want to FOIL x minus 4 times x minus 5. So if we take our first terms, we have x times x, that's x squared. Our outer terms, x times -5, that's -5x. Our inner terms, -4 times x, that's -4x. And then our final terms, -4 times 5, that's positive 20. Let me get my pen so that works here. Okay, positive 20. Now we combine our like terms here, x squared minus 9x plus 20. And that is what we started off with in the beginning, so our solution does in fact work. Let's look at it. Okay, so here's a second example of a problem that we would factor when the leading coefficient is not 1. In this time, our final number, or our C term, is a negative number. So we're looking for numbers that multiply together to get -18 and add up to positive 3. So multiplying to -18, adding to positive 3. If it's a negative number, we know that one is going to be positive and one is going to be negative. So let's list the factors of 18. We have 1 and 18, so let's make 1 negative and 18 positive. 2 and 9, 3 and 6. And I think those are the only ones, so let's again repeat those numbers, making the opposite number negative, so -6 and 3, -9 and positive 2, and -18 and positive 1. We want to know which of these add up to positive 3. Okay, remember the bigger number gets the sign. So we're looking at -3 and positive 6. So we can rewrite this as x minus 3, because we have a -3, times x plus 6. And that's our answer. Okay, we're going to check that that answer works. We can check that by multiplying these. So we have x minus 3 times x plus 6. If we FOIL that, that is x squared, outer terms, plus 6x. If we multiply our inner terms, minus 3x, and then our last terms, minus 18x. And then if we combine our like terms, that's x squared plus 3x. Oh, let me change my pen there, minus 18. So that does in fact work, so that is our answer. So one thing that's good to look for are some special patterns, and these can really help you make some shortcuts when you're factoring. That's why I like them. First one to look at is if you have the difference of two square numbers. So you have some number squared minus another number squared. Okay, this is super helpful to memorize this pattern if you haven't already. And sometimes I'll refer to this as dots but that just stands for the difference of two squares. It's just an abbreviation. So for example, in this first problem, we've got x squared minus 49. And really we can look at that. That is the number x, which we don't know, it's a variable, squared, minus the number 7 squared. So our first term that's being squared, or what you can think of as a in this pattern, is x. And the other number that's being squared, our b term, is 7. Because that is a number being squared. So if we fill in this formula, x is a and 7 is b, this becomes the product of x minus 7 times x plus 7. And then we're done factoring. So really, if you memorize the special product pattern here, you're doing yourself a favor and doing a shortcut. Okay, and you can, of course, check that this works by foiling. Let's do a second example here. So we've got x squared minus 9. So x is being the number that squared the first part, and then 3 squared is what 9 equals. So 9 is 3 squared. So our a term, again, is x, and b is 3. So this becomes x minus 3 times x plus 3. And then we're done. I love those because they're so simple to do, especially after you memorize the pattern. Okay, the last special patterns that we're going to talk about are if we have a perfect square trinomial. Okay, and that's a trinomial basically that can be factored into something that becomes a perfect square. So here, if we have the first term squared minus 2ab plus b squared, that can be factored into a minus b squared. So this is a perfect square because it's some number, a minus b, being squared. Again, the only thing different in the second one is that our minus sign changes to a plus sign here. Okay, and then so in the formula, instead of a minus sign, we would have a plus sign. So let's look at how that would be, how that would look in some examples. So if we have x squared plus 12x plus 36. Now you can look at that and think, okay, I need factors of 36 that add up to 12. You can factor this normally. But if you recognize that 12 is just 2 times 6 and 36 is 6 squared, then you've got an a term of 1, or just x, 1x, which is x, and your b term is 6, okay, because that is being multiplied by 2x here and being squared in the final term. So if we think of the a is x and b is 6, we can plug it into this formula from above, and we have that that is simply x minus plus 6, excuse me, because we have the sum right here, x plus 6 squared. And that's our answer. If you don't see these right away, you can simply use our old form of factoring, what we've done in the past two slides, and you'll still get the same result. But this is just a shortcut to keep in mind. Okay, in this second example, so we have 26x and negative 169. Well, I happen to know that 169 is 13 squared, and 26 is 2 times 13 times x. So we have x squared minus 2 times 13x minus 13 squared. Okay, so our a term is x, and our b term is 13. So if we plug it into our second formula, or our first formula, because we have a minus sign here, we have x minus 13 quantity squared. And that concludes reviewing Factoring Quadratics Part 1. See Factoring Quadratics Part 2 for the remainder of the lesson.